now we're on the last page of the practice questions. Uh, these ones we have are a little bit different. If I just preview back, here it's y is equal to, and it's a fairly simple expression underneath the radical sign, x plus 1 or 2x minus 4. And so we could start with the y is equal to the square root of x, and then just as a parent function, and then just make a few translations there, or a few transformations. This is a bit more complicated now because we have got this x plus 1 all squared and negative and things like that. So let's do what we learned from our previous example. Let's consider y is equal to negative x plus 1 all squared plus 4. Let's consider that function first, and then we'll do the square root version of it. And you'll recall we found it was very beneficial to find the x-intercepts by setting y to 0 first of all. So if I do that, I'll get 0 is equal to negative x plus 1 all squared plus 4. I'll subtract 4 from both sides. Maybe I'll work off to the right here. I'll get minus 4 is equal to negative x plus 1 all squared. Multiplying both sides by negative 1, I get 4 is equal to x plus 1 all squared. And now when I do the square root of both sides, I'll get plus or minus 2 is equal to x plus 1. So now it diverges off into two versions here. I can get x plus 1 equals 2. I'm just switching the order here. And I can also get, or x plus 1 equals negative 2. So when I subtract 1 from each side, I'll get x is equal to 1. And here I'll get x is equal to minus 3. So I've got a 1 over here, and I've got a minus 3 over here. And now, because it's a negative, I know that x is going to be, or the graph is going to be opening downwards. If I plug in a 0 for x, so again I'll write y is equal to negative 0 plus 1 all squared plus 4. If I plug in a 0 for x, I get 1 squared is 1. I get negative 1 plus 4. I get y is equal to 3. So in other words, 0 comma 3 is, is that right? Will be my 0 comma 3 will be one of my points here. And also, just looking at what I know from the grade 11 from graphing parabolas, my vertex is going to be at negative 1 comma 4. So if I go even higher, so my graph, I got a pretty good understanding here for my sketch what things are going to look like. I think it's going to look a lot like this, like that. Now I need to draw my square root version of it. So again, it'll start, I'm going to have 4 invariants, and they'll be here, here, and then where y is equal to 1 here and here. And my vertex, instead of being at 4, it'd be the square root. Now it'd be at 2. So now my final function, I'm going to make sure I go over that, underneath, and go like that. Okay, and again, it's just a sketch, so that's what it should look like. Let's check out the domain and the range. So the domain, of course, is going to be related to these two x-intercepts. X is going to be greater than 1, and greater than negative 3 and less than 1. So the best way to write that is negative 3 is less than or equal to x, which is less than or equal to 1. And if I put all my good stuff here, I'll put my curly braces, x such that, and then I'll say, and x is part of the domain of real numbers. And for my range, it's going to be between the y values between 0 and 2. So very similarly here, I'll say curly braces y such that 0 is less than or equal to y, which is less than or equal to 2, where y is part of the set of real numbers. Okay, let's try our second example here. We've got x squared plus 1, or x squared plus 2. So we'll consider this one first, and then we'll do the square root of that. So let's look for intercepts. So let's set y for 0. When I subtract 2 from both sides, I'm going to go, oh no, see I can't really do the square root of a negative value, so I'm going to say no solution. And it does make sense too when I think about this y is equal to x squared plus 2, that would look like a y is equal to x squared just moved up 2. So it would be up 2, it's going to look like this, isn't it? So our original function is going to be here, if I go over 2, go up 4, kind of goes. So there is my y is equal to x squared plus 2. So now when I do the square root, so when I do y is equal to the square root of x squared plus 2, I do keep all the x values the same, but do the square root of the y values. So here I have 0, 2, so the square root of 2 is about 1.4, so it'll be about there, and so on. So I'll get, just as a sketch, something like that. And my domain here, well, x can be all real values. And for my range, y such that what y is greater than or equal to, and it's the square root of 2, so I'll just put the square root of 2, such that x is, or y is, pardon me, taken from the set of all real numbers. Okay. Now we're going to the extra practice, and these are, if you could do these on your own, that's good, because you're sort of making some extensions that I had kind of alluded to but weren't too explicit about. It says write the equation of a radical function with each domain and range. Okay, so there's more than one answer, but there's certainly one simplest answer. So if I think about my parent function of all these radicals of the basic y is equal to x square root of x, I get this, right? And the domain for this one is x is greater than or equal to 0, and my range is y is greater than or equal to 0. And now I think about what type of transformations. Whenever I move something to the right, then this increases, right? So if I were to go like this and move something to the right and say if h was equal to 2, in other words if y is equal to the square root of x minus 2, then things would go to the right, and instead of x is greater than or equal to 2, I would get x is greater than equal to, or instead of x is greater than or equal to 0, I would get x is greater than or equal to 2. So whatever the h value is here, I could say this for the domain, right? And also I could say this for the range, it would be the k value. So in other words, here, what we want to have is an h, which is equal to 2, and the y, or the k here, should be equal to -1. So the easiest way we could answer this question, we could say that y is equal to the square root of x. Since h is 2, I'll say -2, and then outside of here, just make some room for myself, -1. Okay, for my next question here, I've got x is less than or equal to -5. Okay, so two things have happened. The first thing you'll notice is that this greater than turned into a less than. So how do we do that? So instead, if I start with this function, and if I want x to be less than or something, that means I have to switch to this. So what happened? I had a reflection over the y values, or my x values got multiplied by -1. In other words, my b is equal to a negative, right? If it's simply a -1. So in this case, I could say, because of this switch right here, b is going to be equal to -1. And then afterwards, because of this -5 business, I went left 5, so h is going to be equal to -5. This is still, this has not switched, and here I've gone up 7, so my k value is going to be equal to 7. So my answer for this one would be y is equal to square root negative left parentheses x. Now if h is equal to negative 5, I write plus 5 here. And now I say plus 7. Okay, so if you're not sure, if you're doing a question like this and then you needed to check it out, to graph it, clearly you could either use GeoGebra or Desmos.com and then just see if it works. So I don't think it would be a problem. Question number 2, it says determine the equation of the following function written in the form. So we have to figure out what a, b, h, and k are. So like we did before, the first thing I want to do is look at these 2 points and realize that they originated from 0, 0, 1, 1, right? So here's my original function. What happened here? So my x, the difference between my x values here, this is just 1. And in my parent function, the difference between my y values is also 1. So let's see what happened here between these 2 points. Here my x values are still at 1. Maybe I'll switch to a different color. Are still at 1. But my y values are a difference here of 2. So in other words, what happened? My y values have been multiplied by a 2. And in all this stuff here, what is the thing that multiplies the y values? It's the a, right? So in other words, therefore, a is equal to 2. Okay, so that's the first thing we'll look at. And then what about the shifts? What about the left and right and up and down? So if I do a bit of erasing here, if I started, I'll put that back. This has gone left 3, and it has gone down 2. The left 3 means that h is equal to negative 3 and k is equal to negative 2. Alright, so at the end of the day then I'm going to write this as y is equal to, I'll write my 2 first, times the square root of, the b value is 1 so I don't have to write it, x, and since h is minus 3, I write the opposite, I write plus 3, and then outside of here is where my k value goes, and so it's minus 2. So again, you could check that out if you needed to, and just check your work on Desmos or GeoGebra. Alright, so our last one here, it looks like there has definitely been a reflection, so let's just address that first, and then it'll be sort of clear in our mind what's going on. So here's our parent function. So it looks pretty clear to me that although there has been some shifting left and right as well, there has been a reflection on the x-axis, right? Because a reflection on the x-axis would make things go like this, right? And then there's also been some stretches on things like that. So there has been a reflection, I can't spell, reflection over the x-axis, which means that the y values have been multiplied by negative 1. So the y values be multiplied by negative 1, so in other words that my a is equal to negative 1. So that part is pretty good, and now let's just see about whether or not, or I should say the a is negative. I don't know if it's negative 1, but I know it's negative, so maybe I'll just rewrite that. A is negative. Okay, so now let's just see here about the between these 2 points. Here, the x is 1, and my y value is, it goes down 1, 2, 3, 4. Okay, so the fact that it goes down, we know that that's because a is negative. The fact that it goes down 4 must be, so now I know that a is equal to negative 4. So now I just have to figure out my shifts left and right. So if I started at the origin, right, so we're going like this. So this, all I'm thinking about is how did this get over here? It had to go to the right 2. In other words, my h is equal to 2, and it had to go up 3. Okay, so now I'm ready to put it all together. I can say y is equal to, so I got a -4 for my a value times the square root of x, now my h is 2, so x minus 2, and then outside of the radical symbol, plus 3. Okay. Those are a little tricky, so that's why we got some extra ones for you. So good. I hope you did well on that. I think that is our last. Thanks, and we'll see you in class.